All right, so this class tonight is on TXV operation. I'm Ron Walker. I am the founder and course developer for HVAC Training Solutions. And I give these free classes, number one, because I enjoy them, number two, because I have students in my class that can benefit from them, and three, so that if you're thinking about HVAC training or a career in HVAC and would like to learn, hopefully you'll learn from me, because this gives you just a taste of how we do it. So if you haven't been with me before, when I go to the screen share mode, I won't be able to see any comments that you type in the chat box. So if you have any questions, I'll check back in after we do the screen share, and I'll give you an opportunity to ask some questions if you have any. Then we can go back and answer them and learn together. So I'm going to go ahead and we'll get started here. Okay, so tonight's topics, we're going to cover the valve construction for the TXV, how the valve operates, and how to properly place the sensing bulb when you're replacing a TXV, and also when you're troubleshooting one to make sure it's mounted correctly. Now, here is a cutaway view of a TXV valve, and a couple of things to point out, and you can see all of the different parts of it, but let me just show you how this works. The refrigerant, and we're going to go into this in detail, but I'll just show you the path. The refrigerant comes up this tube. There's the screen right here that you see. This filters out any large debris, and this is sometimes an issue with the TXV valve if it gets plugged up because of a bad installation. Usually that doesn't happen. The refrigerant flows through, and then it flows down through the needle and orifice, and then out into the evaporator coil. Now, the refrigerant that is here in green follows that path and only stays within this part of the valve, so it only follows this path right here. Anything above or below that, the path here has no effect on it. The refrigerant won't flow down into the bottom of the valve or up into the top part of the diaphragm. And I'll just back up here just a bit. It does push up here in the bottom of the diaphragm, and we'll go into that in detail here in just a bit. All right. A couple of things. This is the diaphragm up here, and this is part of the closing force of the TXV, and we'll look at this again in more detail. These pins are connected to the bottom of the diaphragm, and it pushes down on the piston. So that's your downward and opening pressure, and then we have the suction line pressure pushes up on the bottom of the diaphragm, and we have spring pressure. So we have three different pressures that open and close the TXV valve. All right, so let's take a little bit of time and explain what we're looking at here. We have two different views here, one of the TXV and then one of the evaporator circuit. So the little magnifying glass here is depicting the cutaway of the TXV valve, and we'll go through this one by one. So here's our sensing bulb, and it is mounted to the outlet of the evaporator coil. And it is inside of the sensing bulb is usually the same type of refrigerant that is in the system. So in this example, we're using R22. So the TXV valve would have R22 refrigerant in the sensing bulb itself. And right here you can see it is a sensing bulb, and it is partially liquid and partially vapor, and that means it's in its saturated state. So any increase in temperature on this bulb here is going to expand the refrigerant, boil off some more, and it's going to apply downward pressure on the top of the diaphragm, and that is our opening pressure. And the opening force for a TXV is the bulb pressure. That is the only opening force on a TXV. So, for example, in this example, we have R22 refrigerant at 54 degrees. Now, you see right here, this sensing bulb is mounted to the outlet of the evaporator, and if you put your thermometer on there, it's 54 degrees. So, using the pressure temperature chart, you can cross that over from 54 degrees is 91 pounds per square inch of opening pressure on the top of the TXV valve. And that's going to start pushing that diaphragm down. It's going to open up this valve seat right here, and it's going to start to allow that refrigerant to flow through the valve seat and out into the evaporator. So that's not the only pressure, otherwise it's going to push this valve open as far as the design will allow and just flood the evaporator. We don't want that to happen. So here's our evaporator pressure right here, and it flows through the valve and it pushes upward on the diaphragm from the bottom side of the diaphragm. And the evaporator pressure is 67 psig. Now, if you have your gauges on there, 67 psig and 40 degrees Fahrenheit of the refrigerant, and that's, and if you cross that over to on your pressure temperature chart, that is 67 psig. So now we have 91 psig pushing down from the bulb temperature, which is 54, and we have 67 psig pushing up on the bottom of the diaphragm. So now we start to have the opening pressure and the closing pressure starting to oppose each other and starting to balance out. So let's go on to our next. Let's go onto the next. And now there's spring pressure right here, and this is where you get your superheat for a TXV. And that spring pressure helps maintain equilibrium, and if it's designed for 14 psig of pressure, then you're going to have the proper 14 degrees of superheat down here at the bottom. Now, let's talk about a little bit what happens with all of these forces when things start to change. Let's say, for example, we take this sensing bulb off of the 54 degree evaporator, the outlet of the evaporator, and we dropped it into a warm glass of water. What's going to happen is the warmth from that water is going to start to cause this refrigerant to boil even more. It's going to increase the pressure on the top of the diaphragm, and it's going to push the diaphragm open, and it's going to allow more refrigerant to flow through to the evaporator coil. So the same thing happens if the bulb is reattached and this goes up. Someone opens the door in the home, and the sliding glass door is open. It's 90 degrees outside. We start to get a more heat load. What will happen is the outlet pressure temperature right here is going to start to go up. So when the outlet temperature goes up, the bulb pressure increases, pushes down on the top of the diaphragm, and it allows more refrigerant in to maintain proper superheat and to adjust for any varying cooling loads. And the same thing happens in reverse. If it starts to get into the evening time, the outlet temperature starts to drop here, the bulb pressure decreases, and then it has less opening force and closes just a bit more and maintains superheat. So it is a temperature sensing device, and it will maintain a very stable superheat the one thing is when you're checking pressures and temperatures with the TXV system, you need to allow 15 minutes for everything to stabilize, because at the start of the cycle, it's going to be hunting a little bit, so everything's going to move up and down until it reaches that equilibrium. So I'm going to pop back here to the screen. Does anyone have any questions so far? Is this about as clear as mud, or are we good to go? Now's your chance to type them in. Okay. Okay, good. All right, so let's move on. Okay, so the sensing bulb that we're looking at here, where it's mounted on the outlet of the evaporator, it is important that you mount it properly. If the outlet of the evaporator's refrigeration piping is 7/8 inch or greater, is greater than or equal to 7/8 inch, you need to make sure that the sensing bulb is placed either at 4 o'clock as you look at it, or at 8 o'clock as you look at it, or 4 o'clock as you look at it. And we'll check, and we'll explain why in just a minute. Now, if the outside diameter is less than 7/8 inch, then the bulb can be placed anywhere between 4 and 8 o'clock here. Now, you never want to place it at the bottom, and it's a pretty good idea just to keep it right here at the 9 and 3 if you can. It's just not always possible to do that. The reason being is the TXV sensing bulb senses the temperature, and if it's right on the TXV bulb is up here at the top, it's a little bit warmer at the top of the tubing because the vapor rises to the top, and it's going to throw the sensing bulb off a bit. And then there's oil on the bottom, and that insulates the sensing bulb from responding quickly to the temperatures, because that oil has to heat up, and if it flows from a cooler place down here to the bottom, it's always going to be changing temperature. So it's a good idea to keep it at 3 and 9 o'clock if you can do it. Okay, so that works well in all size pipes. So when in doubt, mount it at 3 and 6 o'clock. Here's something that can happen if you're not paying attention, and something to look at if you're troubleshooting with a TXV problem, is improperly mounted sensing bulb. It's very easy if you have a braze joint here or coupling to mount that sensing bulb and not have it securely fastened and touching the evaporator coil. So you just need to make sure that you have great bulb contact here, because it's got to sense that temperature so that that TXV will react properly. Now the TXV bulb on a vertical line, you don't want to do that if you can help it. It's designed to be on the horizontal, but it will work on the vertical. But you must pay attention, because if you mount it the wrong way, you have liquid going back down to the top of the diaphragm, and it's going to throw the sensing bulb off, because there's no liquid in the bulb to boil, because most of it will have drained down into the top of the TXV, and that's going to throw things off too. So always make sure that you mount it with the outlet of the sensing bulb and the tubing at the top of the bulb. All right, now let's go back real quick. We'll take a look at this cutaway one more time. If we have a TXV valve that isn't operating properly, and what can go wrong, there are times, and I've seen it happen. It's an expensive repair for the customer, but due to improper installation practices and brazing practices, debris gets caught up in the screen right here, and it will plug off. It'll start to plug up the refrigerant flow and hold back this refrigerant flow, and it's going to start to starve the evaporator for refrigerant. There's absolutely no way to check that unless you pull that out and check it and clean it and put it back in again. So make sure that if you do have a TXV valve that's starving, before you replace that valve, you pull that screen out and look at it and clean it. It's always good to have an extra TXV valve on hand to make sure that if it is a bad TXV valve and the screen is clean, that you can replace it at the time, because it's a lot of work just to check this little screen right here. Now, here's what usually goes wrong with the TXV valve, and that is this connection of the tubing up here at the top of the diaphragm is pretty fragile. And this tube here is about the size of a pencil lead. It's very small. And there's vibration, and it gets moved around during installation and so forth. And this junction right here tends to break over time and leak. So it leaks out all of the refrigerant from the sensing bulb. So there's no more downward pressure to open up the valve. And we still have, because it's only leaked out of the sensing bulb, we still have evaporator pressure pushing up to close it, and we still have spring pressure pushing up to close it, and it tends to starve the evaporator for refrigerant. Now these valves rarely slam all the way closed and block off the refrigerant, nor do they open up 100% to let the 100% refrigerant go through. There's a range that it operates. So when the sensing bulb loses its charge and there's no opening pressure, the spring pressure and the evaporator pressure don't close this seat all the way. It just starts to starve it for refrigerant, and what you'll find is you'll have all the pressures will be good as far as charging, and the charge will be correct, but as it's going through this tiny little opening right here, it'll start to freeze up this valve, and it'll start to freeze the evaporator coil going down the line, usually about halfway down, and it'll be an iced up TXV and an iced up evaporator coil. It's a pretty sure sign. Now remember, if you want to check to see if this is operating properly, you can take that valve off and drop it in a warm glass of water. It's going to apply maximum amount of opening force on the diaphragm if there's refrigerant in here, and you should see that ice begin to go away if this valve is working properly. All right, hopefully that makes sense for everybody. Okay, so we're gonna go back, and I'll answer any questions that you may have. Again, if you like this training, you'll love the HVAC technician class or the NATE training classes that we have. If you're interested in doing that, this is the fee that I charge. You have to listen to my commercial before I let you go. So if you would like to learn about HVAC or further your HVAC training, please shoot me an email or stick with me after the end of the class. All right, so any questions for me? Short little TXV class, but this bite-sized chunks is how we do it. Thank you, Dwight. Hopefully that all made sense. We've got a recording going on this, so if you need to rewatch it, please. All right, well, I'd like to thank you all very much for attending. Keep an eye on the website. I'll be posting up some more classes, bite-sized chunks, and I hope you enjoyed this. Any requests for training, please email me. I'm always up for ideas. All right, thanks very much, guys.